solve the differential equation d square y by dt square plus 3 dy by dt plus 2y equal to e power minus t with y of 0 equal to 1 and y dash of 0 equal to 0 using Laplace transform. So now to solve this differential equation we have to use Laplace transform method. So these are all formula we have to apply to solve the given differential equation. Okay, so this is as usual formula. Here I'm going to use these formulas. Okay, now the problem is the given differential equation can be rewrite as, this is the second degree, so this second degree equation can be rewrite as y double dash of t because the variable involving t, so that I'm returning y double dash of t plus 3 into, this is first derivative dy by dt, so that this is y dash of t plus 2 into y, simply y, so y can be written as y of t is equal to e power minus t. Okay, now to solve this differential equation by Laplace transform method, I want to take Laplace transform on both sides. So taking Laplace transform on both sides. So now taking Laplace transform, so L of y double dash of t plus 3 into L of y dash of t plus 2 into L of y of t is equal to L of e power minus t. So now I am going to apply that formula. Already we know the formulas. L of y double dash of t. The formula is s square y bar minus s into y of 0 minus y dash of 0. So this is the formula for L of y double dash of t, and plus 3 into L of y dash of t. This is the formula s into y bar minus y of 0 plus 2 into first formula L of y of t is y bar, which is equal to the another formula Laplace transform of e power minus t. The formula is 1 by s plus 1. Okay, now I am going to substitute given initial condition. The given initial condition is, and conditions are y of 0 equal to 1 and y dash of 0 equal to 0. So substituting these two conditions in above equation, therefore s square y bar minus y of 0 is 1, so 1 into s is s, minus y dash of 0 is 0 plus 3 into s y bar minus y of 0 is 1 plus 2 y bar equal to 1 by s plus 1. Okay, now I want to separate y bar in the left hand side, taking other terms in the right hand side. So now what are the y bar terms? These are all y bar terms. This and this. So in the three terms, take y bar term outside. So s square plus 3s plus 2 into y bar, taking y bar outside. What are the remaining terms? Minus s minus 1. Take these two terms in the right hand side. But this is not minus 1. When you multiply 3 inside, this is minus 3. This minus 3 can be taken in the right hand side plus 3. So that in the right hand side 1 by s plus 1. When you take minus s in the right hand side, this is plus s, and 3 into minus 1 minus 3. This minus 3 can take in the right hand side plus 3. Okay, so now I am going to take LCM. So 1 plus s plus 3 into s plus 1 whole divided by s plus 1. Okay, now in the numerator I am going to simplify. So now you see multiplication of these two terms, s square plus s plus 3s plus 3. So when you multiply this, you will be getting, you see, when you multiply these two terms, you will be getting s square plus 4s plus 3. When you multiply these two terms, you will be getting this. But here 1. So 1 plus 3, 4. So in the numerator, you will be getting s square plus 4s 3 plus 1 4 by s plus 1. But in the left hand side, this is s square plus 3s plus 2 into y bar. But I want y bar term. Take this term in the right hand side. Okay, now y bar is equal to, in the numerator, a square plus b square plus 2ab, so that it is s plus 2 the whole square. The numerator is s plus 2 the whole square, whole divided by s plus 1 into, this is the term. The factorization of the term is, s plus 1 into s plus 2. So this term can be taken to the right hand side. It becomes s plus 1 into s plus 2. But you see, one s plus 2 term will cancel. S plus 1 into s plus 1, s plus 1 the whole square. But at the same time, we know y bar is equal to what? You see in the formula, y bar is equal to L of y of t. Therefore, for this y bar, I can substitute L of y of t is equal to, in the numerator, s plus 2 divided by denominator s plus 1 into s plus 1, s plus 1 the whole square. Okay, now in the differential equation, always the solution y of t. The y of t is always the solution. So y of t is equal to L inverse of s plus 2 divided by s plus 1 the whole square. Okay, and now I want to find out the inverse Laplace transform of this function. Okay, so now here we cannot apply partial fraction method. So I want to apply some different method. Here, you see this numerator s plus 2 can be written as s plus 1 plus 1, because I want to convert the numerator like the denominator. You see L inverse of, the denominator is s plus 1, so that the numerator 2 can be written as s plus 1 plus 1 divided by s plus 1 the whole square. So this is the one methodology to find the inverse Laplace transform. Okay, so now consider the entire term like a single term. So s plus 1 by this plus 1 by this. So L inverse of s plus 1 by s plus 1 the whole square plus 1 by s plus 1 the whole square. But you see, 1 s plus 1 will be cancelled. At the same time, I am going to take L inverse inside. So L inverse of 1 by s plus 1, 1 s plus 1 cancel, take L inverse inside, plus L inverse of 1 by s plus 1 the whole square. Okay, so this is direct formula. One L inverse of 1 by s plus a, e power minus at. A is 1, so that it is e power minus t. So this is the formula, L inverse of 1 by s plus a is 1. So e power minus at means minus t. But you see, this is by shifting property. In the shifting property, this s plus 1, I want to replace by s. By replacing s plus 1 by s, for that we have to write s plus 1 means e power minus t. By shifting property, by replacing s plus 1 by s, for this I want to write e power minus t, L inverse of s plus 1 is s, so that this is 1 by s square. This is inverse form of shifting property. You should know the inverse form of shifting property. The inverse form of shifting property is the s plus 1 is replaced by s. Instead of that, you have to write e power minus t. Here plus 1 means minus t. Minus 1 means plus t. Plus 2 means minus 2t. Minus 2 means plus 2t. So this is inverse form of shifting property. For example, you can see the inverse form is L inverse of what is that? 1 by s plus a the whole square. But replacing s plus a is replaced by s means, for this you have to write e power minus at, and then L inverse of this s plus 1 is s plus a is s, so that this is s means s square. So this is the inverse form of shifting property. but here a, but here 1. And next I am going to apply the formula L inverse of 1 by s square. L inverse of 1 by s square is t, because you know this is also the formula L inverse of 1 by s power n formula. So that this is e power minus t plus e power minus t into L inverse of 1 by s square is t. So this is the answer of the problem. So e power minus t plus t into e power minus t. So this is the solution of the given differential equation.